Okay, so the focus of the lesson this week will be about more focused on writing code and communicating with the Arduino. Okay, so we're going to call this project Serial Monitor because that's what we're going to be working on. We're going to be using something called the Serial Monitor. Let's call it Serial Monitor Intro. And what we're doing is it's a tool that we use to communicate with the Arduino. So the very first thing we want to do is type in this line, serial.begin, and we're going to put this number 9600, and all that does is it basically tells the computer the rate at which the Arduino is sending the data. And so this, for now, this number is kind of irrelevant to us, but we just have to put it there in order for it to work, to function correctly. And then later within our loop, we're going to add this function serial.print, and what's going to happen is while the Arduino is running, it's going to send out whatever information is located right here. Okay, so this is a very basic Arduino program. Let's try it out. Let's tell it to print the number 2. Okay, now I'm going to say run on Arduino. So it's running it to the Arduino. Or maybe not in this case, this one appears not to be working. Okay, there we go. So now what I do, once it's uploaded, I'm going to click this button right here for Serial Monitor. I'm going to click to connect, and here you see the number 2 being printed. Okay, just not very useful program, but what's happening is the Arduino is sending the number 2 to the computer, and it's printing it over and over. Okay, so we're going to go ahead and disconnect. We're going to turn off the serial monitor for a minute, and now I'm going to show you how this might be useful. Okay, not useful, but let's just show how we can maybe use this. So we're going to create a variable. We'll just use the letter I, and we'll say that initially it's going to be equal to 0. Okay, now we're going to replace this to say print I, and what we're going to do is we're going to say that I is equal to I plus 1. Okay, let's verify to make sure we typed in everything correctly. Looks like we're good. Okay, so before we run this, what do you think this is going to print this time? Remember, this loop runs over and over again, so what do you think is going to happen as this loop runs? Alright, let's go ahead and try. We're going to run it on the Arduino. Let's turn on our serial monitor and connect. Okay, so there you see it counting up and up and up. It's kind of hard to tell because it just throws everything in one line. Okay, so what we can do to make this code a little bit easier, one thing that might be nice is if we add a delay, so it waits a little bit before putting the next one. So let's say we delay 1/10 of a second or 100 milliseconds between each print. Okay, now let's try that. Alright, so now we're going to click connect, and we'll see what happens this time. Okay, and so now you see it waiting longer and longer between each print. Okay. Alright, still kind of not very useful because it keeps just stacking them on together. So what we can do now is we can say, okay, when we print, we can change this function to print ln. And what makes this useful is that every time we say ln there, it skips to the next line. Okay, so let's verify the code now and see what that looks like. Okay, so we connect, we see it counting up. Okay, and let's go ahead and disconnect it. Okay, so you see here that these numbers, sometimes it repeats the same number twice, and what's happening there is that this loop is running at a certain rate, and this 9600 represents the rate at which it's grabbing data points, and so it's actually grabbing data points faster than the loop is running, and so sometimes it's grabbing the same number twice. That's why that's happening. It's not a problem, it just is kind of something that's going on there. Okay, so let's go back to our loop. Let's try out something else. Okay, so within our loop, we're going to say if I is less than or equal to 10, and then we're going to use our brackets here to kind of create a grouping there, and we're going to move this print into there. Okay, and then I'm going to move this increment here to the end. Okay, so here's what's going to happen. We enter the loop, we have this if statement that says if I is less than or equal to 10 to print I, and then it adds 1 to I and runs the loop again. What do you think will happen when we run this loop? Let's go ahead and see. Alright, so it's been run on the Arduino. We're going to connect. So it prints, and then it stopped at 10. The reason why is because when it's running this loop, if I is greater than 10, when it says if I is less than or equal to 10, that statement comes back to be not true, and so it doesn't do what's within these brackets. So this right here, this if statement, is a really useful tool to make a decision within your program. You're going to look at information, you're going to test it, and make a decision based on it. We can also say, add to it, an else. So now we're going to say if I is less than or equal to 10, print the number I. Otherwise, we'll say serial.print line and say that in quotes here, I is greater than 10. So once I is greater than 10, it's just going to print that. Now let's try that out. And we'll go ahead and connect. And now it says I is greater than 10. Okay. Let's do one now where, let's go ahead and erase all this. We can also do operations with I. Okay. So we'll say serial dot print, and we'll print out I. Okay. And then we'll say I is equal to I times 2. Okay, and then we'll say delay 100. Okay, what do you think this one will do? Let's go ahead and try it. Alright, we connect, and we see, oh, it's just saying 0 over and over again. Why is it just saying 0 over and over again, do you think? Well, the reason why is this. We didn't say to increase the value of I. So let's do this. Or I guess if I started with 0. So let's change it so that I starts as 1, because we just kept multiplying 2 by 0 and getting the same thing. Okay, so let's try that now. We connect, and you see the number getting doubled. And then you might notice suddenly the number turned out to be negative and then disappeared. And so what's happening here is this. In this computer program, when we declare like this variable, that variable can only store a certain amount of information, and so it can only store numbers up to a certain size. And once those numbers get past that certain size, it's just giving us 0 because it can't store a number. It just reverts back to 0, and so now that it's got 0, it just keeps giving us 0 again. Okay. So let's try a different one. Let's change this back to 0, and this back to +1, and we're going to print I divided by 2. Okay, so 0 divided by 2 should be 0. 1 divided by 2 should be 1/2. Okay, 2 divided by 2 should be 1. Alright, but look at this. When we created this number, we called it an integer, which means it has to be a whole number. So what's going to happen here is this can only give us a whole number. I can only be a whole number. Okay, so let's go ahead and try this out. So we connect, and we see that we just get 0, 1, 2, 3, 15, all the way up, but we're never getting those half numbers. And so what happens is, when we divide by 2, it just rounds it down. So for example, 3 divided by 2 is 1.5, it's going to return just a 1. Okay, so if we do want to include those half points, we have to tell it that it's not just an integer, and so we're going to use here a statement to say that it's a float. If we create a float, what that does is create a floating decimal point, and now we should be able to get those decimal values. So we connect, and there you see we get those intermediate values. Okay? I'm going to try one more thing. We're going to, whenever we put an equal sign, we can change the value of I. So let's say I is equal to 2, I is equal to 4, I is equal to 7. Okay, so here I said I is equal to 0, and then I changed it a bunch of times, and then I'm printing I. Okay, when I print I, what number do you think is going to show up? I'll add a delay so it doesn't print it a bunch of times. Let's go ahead and see. Reconnect, and it just says 7. Okay, so even though I was equal to 0, and then 2, and then 4, it only takes one value, and it's always going to be that most recent value. Okay.